In this video, we are going to practice solving quadratic equations by completing the square, and in particular finding the zeros of quadratic functions by completing the square. So at the top, we have the steps that you should take in order to find the zeros of a function by completing the square. And we will go through these steps as we work on the first problem, part A. So step one, we set the function equal to 0. Step two, if a is not equal to 1, in other words, if the x squared term is not equal to 1, divide both sides by a. In this case, a is equal to 1, so we can skip step 1. I forgot to equal 0, so let me do that. Next, step 3, we move the constant term to the other side of the equal sign. Since it's a positive 2 on the left-hand side, it will become a minus 2 on the right-hand side. And 0 minus 2 is just negative 2, so we can just move it over there. All right, step 4, we're going to add b divided by 2 squared to both sides of the equation. So first we have to identify what b is. B is equal to 4, which means that b divided by 2 is equal to 2, which means I just square that number and I get the number that I'm looking for. So 2 squared is equal to 4. So I'm going to add 4 to both sides of the equation. So whatever your x term is, divide it by 2 and then square it, and you're going to add that to both sides of your equal sign. Step 5, we're going to apply the general rule that x plus some number k squared is always going to be equal to x squared plus 2kx plus k squared. Now, in this case, our k, right, k squared has to be equal to 4 because our constant term is positive 4, which means that k is equal to positive 2. Now, the way we know it's positive is because our this term right here is a positive. Our x term is positive, so we're going to use the positive version of k in this case. And so we know that x plus 2 squared will be equal to, and negative 2 plus 4, by the way, is just 2. If you want to double check your work, x plus 2 squared is equal to x plus 2 times x plus 2. X times x is x squared. X times 2 is 2x plus 2x plus 4. And we just multiply these two monomials, combine the like terms, and we see that, yes, x squared plus 4x plus 4 is indeed equal to x plus 2 squared. Next, we take the square root of both sides of this equal sign. And make sure, when we take the square root of the other side, that we put a plus or minus in front of it. The square root and the square cancel each other out. Those are inverse functions. And now we're going to solve for x. So we're left with x plus 2 is equal to plus or minus the square root of 2. And so I'm just going to move that positive 2 to the other side of the equal sign, where it becomes a negative 2. And that gives me my two answers, which are x equals negative 2 plus the square root of 2, or x could be equal to negative 2 minus the square root of 2. And those are the roots of this function, or the zeros of this function. All right, let's do one more just to make sure we understand that. I'm going to circle my final answer, and let's try problem B. All right, again, first we set the equation equal to 0. So 2x squared minus 3x minus 1 equals 0. Here, unlike in the previous example, our x squared term is not equal to 1. So a is not equal to 1, so we have to divide both sides by a. Now I'm basically going to distribute that dividing by 2. So each term on the left-hand side gets divided by 2. And notice that basically 2 divided by 2, these cancel out. Now the other fractions, negative 3/2 and negative 1/2, can't be simplified. And so what we're really left with is x squared minus 3/2 x minus 1/2 equals 0. All right, let's look at step 3. Step 3 tells us that we should move the constant term to the other side of the equation and change its sign. So we change that negative 1/2 into a positive 1/2 and move it to the other side. And next, we're going to add b divided by 2 squared to both sides of the equation. So b is equal to negative 3/2. And so we are going to first divide that by 2, which is the same as multiplying it by 1/2. And we end up with negative 3/4. And then we square that. Now negative 3 squared is positive 9. Well, you know what, I'll do this a little bit. So I'm going to distribute that square. I end up with positive 9 over 16. So I want to multiply both sides by positive, or I want to add 9/16 to both sides of this equation. And I'm going to simplify the right-hand side, and notice 1/2 is really the same as 8/16. And so this ends up being 17/16 on this side. Okay. So I guess that was step 3. And let's go to step 4. I'm sorry, that was step 4. This was step 3. That was step 4. And now we can get to step 5, where I'm going to express the left-hand side as sum x plus or minus some number squared. Now, since my x term has a negative sign, I know that this is going to be a minus. And the general rule is it'll be k squared, right? So I look at I'm looking at this rule right here, and in particular, I know that whatever this number is squared, I'm going to take the square root of it, and that's what goes underneath here. So the square root of 9/16 is 3/4. Step 6, I take the square root of both sides. Making sure I put a plus or minus in front of the square root on the right. On the left, now I'm just going to solve for x. On the left, I'm left with x minus 3/4 equals. On the right, I'm left with plus or minus. And the square root of 17 is really the same as the square root of 17 over the square root of 16, which is equal to the square root of 17 divided by 4. So I'm simplifying that. And to solve for x, I'm just going to change that negative 3/4 into a positive 3/4, move it to the other side of the equal sign, and we have our final answer. So this means that x equals 3/4 plus the square root of 17 divided by 4, or 3/4 minus the square root of 17 divided by 4. And that is my final answer on this one. So those are 2 examples of how to find the zeros of a quadratic equation by completing the square. The second one is obviously fairly complicated, but nothing that you can't do. If you follow the steps and you do it correctly, you will arrive at the correct answer every time. I hope that was helpful, and we will see you in the next video.